Hi everyone, I'm back, and today I want to talk to you about some strategies on how to study physics. Now, I know that we're all different. Each one of us has a different brain. We're all different people. We study differently, so each one of you will have your own strategy. And there's no strategy that works better than the other. It depends on your way of learning, on your mood, and many other factors. So it doesn't make any sense to talk about the best strategy for studying physics, but I believe that there are some general guidelines that apply to every person and every style and should be followed in order to achieve best results. So the first thing you want to do when you study for physics or any other science in general should be to read a book. So each week, depending on the pace of your class, you'll be assigned to read a chapter or more or less. So the first thing you need to do is grab your book for your own class, pick it up and read it. Now, the thing when you read for science is that you have to read very carefully. Reading for science is not like reading a novel. It's not leisure reading that you can do on your own time and do it 10 minutes now, 15 minutes later, and hope to get results. You won't get results if you do it that way. First of all, you need to set some time for your reading. So whether it's 30 minutes a day, 45 minutes a day, an hour a day, it depends on your schedule, but you need to set time out for your reading. And when you read, you should not have any distractions. So I know that all of us are addicted to phones, computers, music, and so on and so forth, but if you want to learn science, you have to give it your full attention. So you should turn off your phone for that time, turn off your computer. Maybe if you want to have some background music, that works, but give your full attention to what you're reading. So the point is, read very carefully. Now the other important thing is, it's not enough to read, because as we all know, when you study science, reading is not just a matter of reading text, but there are equations in the text that refers to concepts. And generally, depending on the book you're using, equations are given in steps, but not all the steps are shown. So the best thing you can do to learn properly will be, in my opinion, to always have a piece of paper and a pen and a pencil and try to fill in the steps. So if you start from equation 1 and the book says, here's equation 1, here's equation 2, and you have no idea how they got from equation 1 to equation 2, the best way to understand that is try to work it out yourself. Now this, of course, requires a little bit more time, but it's a very effective way of learning the concepts, because sometimes missing the steps that lead from point A to point B might actually lead to a misconception or a misunderstanding of the concepts. So that's the first thing you should do always. And I believe that applies to any subject. If you read history or political science, you don't need to derive the equations, but even in that case, you need to read the book very carefully. The second thing that I think is fundamental is that you attend the lectures. Now, you have no idea how many times I tell my students, please come to the lecture. It's not a matter of attendance. I personally don't take attendance. I think, especially at the college level, taking attendance and punishing or rewarding the students for showing up to class is just silly. On a personal level, you pay for the class, so it should be your responsibility to go to class if you want to learn. If you don't want to go to class, it's your choice, you pay. I'm not gonna consider you liable for it, and I'm not going to punish you. But at the same time, I'm not gonna reward you for doing what I expect to be the minimum requirement when you're in college. So the reason for going to class is what? Because I get this question from a lot of students. A lot of students say, well, you don't take attendance, we don't lose points for not coming to class, we don't get any points for showing up, so why should we come to class and listen to you when we can read the book at home? And the reason for that is interaction. So let me explain. It is true that when you read your book, all the concepts that you need to know are right there in the book. However, especially as an inexperienced learner, meaning someone who's learning that stuff for the first time, You are on your own when you read the book, and you have tons of questions. And whereas the book has the topics in it, it does not have the personal interaction that you can get in a classroom. Okay? So hopefully your instructor, when he or she teaches the course, doesn't just repeat what's in the book, but they probably expand and try to explain things more in depth or in a different way, or at least they try to give you their point of view on the topics. So the reason for going to class will be for you to, first of all, formulate questions that you might have from what you read and ask those questions. So in other words, interact with your instructor, interact with your peers, because you can learn a lot both from your instructor and from your peers. You can learn from your instructor because you can ask questions, and your teacher, your instructor, can respond in a sensible way to those questions by maybe explaining the concepts in a way that is different in the book, that perhaps did not make too much sense to you, or showing you how to derive a step, because as I said earlier, you might try to derive the steps in the textbook, but you might fail, and that's, part of the game. So you might ask your instructor, I don't see how they get from equation 1 to equation 7 in the book. I don't think they explained it well. Can you go over that with me? So that's one reason. The other reason is you probably will do your homework and you'll struggle with it and you'll get stuck. So that's your time to ask questions about these things. So the point of going to lecture is not to get the same information from your instructor that you can get yourself from the textbook, because that should not be the point of the lecture in the first place. So that's why I tell my students, try to be an active learner. And by that I mean try to interact with me as much as you can. Ask me questions, stop me, put me on the spot and say, how did you do that? How did you derive that from that one? Can you show me the steps? Can you explain in a different way? Can you go a little bit more in depth on this topic here? Because this is what an instructor is for. Once you've done these two things, are you done? No. Then comes the most important step in the learning process, and that is doing your homework. Now, this is a point that cannot be overestimated. It cannot be emphasized enough how important it is to do the homework. There's only one way to learn science, and that is to try to solve as many problems as you can to the best of your knowledge. Because science essentially is the art of solving problems regarding the natural world. You need to train yourself to solve problems. And this is particularly important when you talk about broad subjects that apply to a very vast array of topics, like in the case of Newton's laws. Now, Newton's laws can be applied to nearly any problem in classical mechanics, and so in order to become good at Newton's laws, you need to solve hundreds of problems on your own. There's no way around this. It's not something that can be avoided, because science comes only through hard work and dedication. I always give this example to my students, and I say, let's assume that you want to be a good soccer player. Is it enough for you to watch soccer games every Sunday and become good at it? No, unfortunately not. You have to put in the time into practice and sweat 3, 4, 5 times a week in order to become just a decent soccer player. If watching soccer games were enough, then I would also be a soccer player, but sadly I'm not. If you want to become a good piano player, is it enough to listen to Mozart all day? No. Maybe listening to Mozart, Beethoven, Chopin, or your favorite classical piano composer might enhance your artistic taste, but it's not going to teach you how to play the music unless you do it yourself and you put into time into practice. And science is no exception to this, which means that you need to struggle yourself with the problems. You need to work out the problems to the best of your knowledge, and when I say struggle, I really mean it. There will be time when you will fail, and there will be multiple times when you will fail, and you'll get frustrated, and you'll hate yourself, and you will not want to hear about physics for a week, and that's okay because that's part of the learning process. It is only when you challenge your brain intellectually, that you put it through the effort, through the challenge, that your brain learns some process, learns how to solve a problem and can move on. So that also means that when you do the problems in your textbook, you can't just pick the so-called plug and chug problems that are easy, where they require very little intellectual effort. All that is needed is plugging in the numbers. Because they might give you a good feeling that you know what you're talking about because they're easy, but they don't teach you anything. A good analogy would be fast food. You can't eat fast food and hope to be healthy. Well, fast food might taste good, but has no nutrients. So you might eat it once in a while, but you shouldn't overdo it because otherwise you're going to harm yourself. At the same time, if you want to learn physics, you can't just do the easiest problems in the chapters and hope to learn the concepts in a profound way. You just have a superficial, shallow understanding, and that's what you're left with. So the bottom line is that you need to work out as many problems as you can, and also pick problems that challenge you. Not problems that drive you insane, but problems that challenge you enough so that you train your brain to think in a certain way and you can move on from there. And this is the most important step in all of sciences. It doesn't just apply to physics, it applies to every science. Practice is really what makes perfect in science. So again, I want to be clear, these are the steps that I use when I study science. I've done it for a decade or more. They've been effective to me. You might come up with your own strategy, but as I said earlier, I think that these are just some guidelines to tell you how to go in the right direction. I'm not saying that I know better than anyone else. I'm just saying that I have a few years of experience and I've tried multiple ways of approaching the problem, and I know which one works better for me and for my students. So thank you for watching. Let me know what you think in the comments below.